Now I'm going to run a desktop client application to finish with the deployment process. But first of all, I will say that I've been working in another branch with the client module and the Jpackage configuration. I've been setting up the Jpackage configuration and other tasks so that in future releases the installation process of the application will be much smoother and easier to perform, like any other installable desktop application where you go like next and install with an installable package. So I'm waiting for Java 17 to come to general availability and finish this configuration for the JavaFX client. And I'm also working on the IP address and with the network interface Java API, so that you don't have to add the IP address manually, and I can get the IP address of the JVM running the application and avoid that extra configuration step to add manually the IP addresses for the server applications and also for the desktop application. So let's go to the desktop section of the documentation. First of all, what you have to know here for this version of the app is that you need the JDK that includes the FX modules. So since JavaFX was removed from the JDK as of version 11 on, then I'm using Java 16. It requires at least Java 16. And then the OpenJDK, the JavaFX modules are not included because you have to add them separately. And I'm also working on that feature to include it into the installable package, as I mentioned before. But right now you have to install a JDK version including the JavaFX mods, and I recommend using the Thulu FX or the Bellsoft Liberica version of the OpenJDK, but you have to take care that you use the FX version to run the application. Otherwise you will get an awful error like this, as you can see in the troubleshooting section. Okay, so I already have all of that. I'm going to check. I'm using VirtualBox and Ubuntu 20.04 to run the desktop application. Let's see the Java version. As you can see, I'm using in my Ubuntu machine the 16.0.2 version, which is the current latest non-LTS version of Java, and stable, of course. And the Thulu version, which is full and includes the JavaFX modules. You can check that by watching the available Java versions that you can install with SDKman. So for example, I have SDKman installed in my VM as SDK, as you can see. And I can see with SDK list Java. You can check all of the available options that you have and you can install. So in this case, as I said, the OpenJDK doesn't include the JavaFX modules. So in this case, you will have to download a Liberica version with effects or the Zulu version here that I have installed, as you can see. Okay. I have also installed all of the other tools that are documented. As you can see, SDKman and Gradle and the Java version with the effects modes. You can go with Java 17 when it comes available, or even right now, but right now is not stable because Java 17 is due to September. And now I'm going to clone the repository, and let's see, through HTTPS. I already have the project here, but I will clone it again. I'm going to rename it to FS. And get into the directory. So here I'm going to require the client module. That's what I'm going to use. And remember that I'm using the development branch because I haven't merged from the development branch to the main branch yet. So to test this application, I will check out to the dev branch. So I'm good to go. Let's see the client module, and let's see what else the documentation tells us. Okay, as I mentioned earlier, I have been working on features to add the IP addresses automatically with the Java APIs, but right now for the current release of the software, and you have to tell the IP address where the JVM is going to run to your Java program. So I'm going to edit once located into the client directory. I'm going to edit this source file and set the host constant to that of the public IP address or host name of my VM. Okay. Oh. Let's see. So as you can see here, this class takes care of obtaining the file system service, and that is basically the remote object to which the desktop application is going to connect and use as an interface to access to the Linux containers and applications that I set up earlier. So what I have to edit here is the host constant. In this case, the registry service is running on the Azure VM. So I'm going to go to the VM, which is this one I created earlier, and let's see, I want to configure a DNS name. It's not necessary, but I'm going to do it. You can see the public IP address of this VM is this one. I'm going to configure a DNS name. So I should add, for example, here fs not available, fs registry, and save the changes. Here are the security groups. So this is just for a testing environment, of course not for a production environment, because I'm going to open all of the ports. And let's see, the source any, all of the ranges any, custom should work. The RMI port is 1099. Protocol any, TCP should be enough. Allow port 1099. Let's add this rule, and it should do the trick for this testing environment. As you can see, the port name in which I'm connecting to the VM is the port 1099, and now the DNS or the IP address is this one. Okay, so that should be the configuration for this file. I'm going to save the changes, and I'm good to go. I've been trying pretty hard to make the cloud deployment of the server applications and then install the client apps and connect to the remote server, but that turned out to be pretty impossible because I got a problem, and I was checking out some facts about it, and the problem is that the system is using callbacks, and well, I have documented the issue here, so the deployment will only be able to be performed in a all-in-one style like this one. So I'm going to continue with I'm going to keep up with the deployment of the desktop application in this virtual machine in VirtualBox, but I'm not going to keep up with the Azure deployment of the two Linux containers because I won't be able to integrate them into the desktop clients because of these problems that I am talking about. You can see some references here, you can read more about it. If I use a callback over the internet, I have to configure firewalls and security groups, inbound rules, and the client machine needs also to be a server machine to export the remote object of the desktop application, and that ends up being a huge mess. And I have also the requirement to deal with more IP and port configurations, and that's not the point of this project. The project is about DevOps, but the other problem is that Java RMI is a pretty archaic technology. It's pretty old and pretty much no one uses that technology nowadays. Then I should just use an HTTP based web technology like WebSockets and implement this application. And of course I'm using Java RMI because it was the requirement for the course, and it's okay. I've been reading about Java RMI, and it is a pretty old technology, but it is not too bad. But it is not a good use case to send a callback to register clients over the internet or a WAN network, because this is really a big issue. And I wrote the corresponding documentation to that issue in this section of the README file. So what I can do later is to use an Ubuntu desktop virtual machine in a DaaS, desktop as a service VM. I see if I will be able to do it later, because I will check out with the further versions of the software, and if I consider it convenient, I will record a video doing this deployment. But it is exactly the same, or almost exactly the same, of doing this local deployment with an Ubuntu VM on VirtualBox, or you can even run the Ubuntu VM from scratch, the actual OS, and deploy the two registry and server container, deploy the RMI applications to each container, install the proxy device to map the local host of the Ubuntu VM to the registry container, and run these clients in the same Ubuntu desktop machine, so you will be able to access without any problem. But the issue comes when deploying this application over the internet, because you have to configure many things, and it might even be impossible to achieve that. So I don't recommend doing so. And the other option, which is quite similar to this one, is to create a wider environment in Azure and create a network, a virtual network, and share that local area network with multiple VMs. So you create a normal Ubuntu server VM to deploy the two containers running the RMI apps, and deploy an Ubuntu desktop to run these clients separately but on the same local area network. So that is another option. In this case, I'm going to check what I have in this machine. With my VirtualBox implementation, I'm going to check out the registry container, and it's running. The server container, and it's also running, and the IP addresses of the container are this one. So you can see I'm passing the registry container IP address to the file system server container here, so that the remote object is bound to this registry container application. And okay, and remind that I will finish configuring Jpackage to create an installable of the application, so that you won't need to do all of these steps manually. So I come here to the desktop client, and I have to install the SDK man to install a Java version containing the JavaFX modules and Gradle, and then to set up the IP addresses stuff, I need to go to this source file. So that's what I'm doing right now. It is where I load and look up for the registry. So in this case, this application is not going to run on Azure. It is going to run or connect to the registry container, which has the IP address sorry about that. .57.94.112. So I save that configuration. That for now I have to do it manually because the software is in alpha version. It's not stable yet, and according to the documentation, I only have to run the client. So let's go to the directory where the project is cloned. Get a client, the client module, and I'm going to run the client desktop application. So the argument that I need to pass to the client application is the client IP address. So in this host VM where the client is going to run, in this case manually I need to know the IP address of the host machine. You can see is the 0.6 192.168.0.6, and if I run the application it has to work. And as you can see, it is connected to the registry container and it has access to the file system server container. I'm going to enter into the server container here in this tab. Get into the directory where the server application is running. See the server module. This is the directory inside the server module where the client files are located physically, all of the client files. So let's go into that directory and let's see what files there are. As you can see, there is the javaeffects.txt and lxc.txt files, which are this one. You can see this if I go to the client local cache of the files. This is the directory where these files are downloaded when needed. This is the binary file system object that is serialized, and this is the object that represents the file system structure that is painted here in this pane. You can see I have a directory called files, and then this directory has files, so this is a tree structure, a tree data structure, and it is serialized into this file. You can learn a bit more about it if you read my suggested reading. This one, where I talk about something interesting about it. Binary incompatibility issues. And so, getting back to the demo, let's see in action. I'm going to pull the javaeffects.txt file to download it locally. As you can see, the file is downloaded, and I can check out the content. I can create many other things here, another directory. Oh, just to be a txt file for now. This is another feature that I'm going to implement for a later version of the software. I'm going to make available the HTML editor to edit HTML files with the styles, and a graphical editor here, so that I will be able to open and work with txt files and HTML files. So I can add some content here. And push the file so I can check out the file structure of this is the file structure of the server of this container into this JVM application. And here it is, the new folder that has been created and the file. I can check out the content of the file. Net this way or this way, cat net rmi. You can see here, and I can delete the files and directories and update the container directory. This is like the master or main directory. And the directory and file that I just deleted have been also deleted into the server directory. And I can run many other clients desktop applications here, and they will be working in real time. If you want to check out the real time functionality, you can watch this GIF animation I recorded where I opened two desktop applications and they work in the same time. As you can see, I perform one change into one application and I can get the updates on the other applications at the same time. And this is the demo for the 0.1.0 release.